Hi friends, today we will do basic syllogisms and some very fundamental rules of syllogisms. Syllogisms usually have three terms. For example, here we have a syllogism. All A is B, some B is C, some A is C. So we see there are three terms, A, B and C. The first statement connects A with B, the second statement connects B with C, and the third one connects A with C. The first two are called premises or statements which are always true. So if we say all cats are dogs, we know it is not true, but for the purpose of syllogism, we have to consider it as true. Now based on the first two statements, we have to check whether the third statement, which is the conclusion, is true or not. And when we say true or not, we mean it has to be true in all situations. Even in one situation, if the third statement is not true, based on the first two statements, then we will say that the conclusion is invalid. Now let us see how we go about solving this problem. All A is B. Let us look at figure 1. The figures are drawn based on the first two statements. Remember, figures will be drawn based on first two statements, and then from the figure we will check whether third statement is true or not. I repeat, the figure has to be drawn based on the first two statements in all possible ways, and then we will check whether in each of the figures we draw, the third statement is valid or not. So, our first statement is all A is B. So we can see we've drawn a set A which is a subset of set B. So all A is B. The second statement is some B is C. So we can draw a figure, the green circle which is C, and we can see that some B is C. So this figure is a valid figure based on only the first two statements. Now from this figure, can we conclude that some A is C? Yes. If you see the figure, C is overlapping with A, and so we can see that some of the A's are C's. Hence, it looks like the conclusion is valid. At least for the first figure that we have drawn, the conclusion is very much valid, so we put a tick mark. Let's go to the second figure. Again, go by statement 1. All A is B. Fine, all A is B. The red circle inside the blue circle indicates all A is B. Some B is C. Again, the green circle, which is slightly inside the blue circle, it shows that some B is C. But based on this figure, can we say that some A is C? Obviously not, because the green and red circle are not overlapping. So the conclusion is invalid in this case. Now as soon as we get in this situation, the conclusion is invalid, we can immediately say that we have an invalid conclusion here. We do not need to check it any further. Still, we will still make a few more figures which are again based on the first two statements. So the third figure, let us check statement 1, all A is B, fine. Statement 2, some B is C, fine. Based on this, can we say some A is C? Yes, we can. So this figure is also valid. Again, we draw another figure, all A is B, where the red and blue circle are coincident. So all A is B. Second statement, some B is C. Yes, some B is C. Based on this, can we say that some A is C? Yes. So it's again valid. So we could draw four different figures based on the first two statements. But in the second figure, the conclusion was invalid. So the answer will be that the conclusion is invalid. Remember, conclusion has to be valid for all the figures that we draw based on the first two statements. Then only we can say that the conclusion is valid. So in this case, the conclusion is very much invalid. Let us try a second problem. All A is B, all B is C, so sum A is C. So we draw figure 1. All A is B, yes. Red circle within the black circle, all A is B. Statement 2, all B is C, yes. Black circle inside the green circle, all B is C. And from these two, from this figure, can we say that the conclusion sum A is C is valid? Yes, very much. We might think here that it should be all A is C, isn't it? Yes, we can write all A is C, that is also valid based on this figure. But all includes sum, so sum A is C is also valid from this particular figure. Let us go to second figure. Here we find A, B and C are the same. All A is B, all B is C, so sum A is C. Again, valid. So we can say that the conclusion is very much valid. If we can draw any other figure where the conclusion can be shown to be invalid, then the conclusion will be invalid for the syllogism as a whole. Remember, the conclusion has to be valid for all the different figures that we draw. Now, if you look at this syllogism, we see there are three terms, A, B and C. Since B is repeated, mind it, since B is repeated in the first two statements, we say B is the middle term. A is the minor term. It comes in the first statement. Apart from middle term, what we have in the first statement is a minor term. And apart from the middle term, what we have in the second statement is the major term. And remember, this is very important, the conclusion will link the major and minor term. So suppose B is the middle term and in the conclusion we are writing sum B is C. It is an invalid conclusion. Sorry. Because the conclusion will always link the major and minor term. Let us look at a third syllogism. Statement 1, sum A is B. Statement 2, sum A is C. And conclusion, all B is C. Again, first two statements are always taken to be true. Third one is the conclusion which we are going to check. Now here we are not drawing any figures. Just go through this statement. This conclusion is invalid. Why invalid? Because middle term has to be distributed in at least one of the premises. I repeat, middle term has to be distributed in at least one of the premises. What does being distributed means? It means it should cover all of A. If you read the first two statements, the common term here is A. So A is the middle term, but we are covering sum A in statement 1 and we are covering sum A in statement 2. So since all A is not covered in either statement 1 or 2, we cannot have any valid conclusion. So if you see that the middle term is not distributed or not fully covered in at least one of the statements, then we can immediately say there is no conclusion. This is called the middle term being undistributed. The middle term being undistributed, there is no conclusion. Let us look at another type of syllogism. Here the first statement says no A is B. Second statement, no B is C. Conclusion, sum A is C. Again, without drawing any diagrams, without drawing any sets, we can immediately say that it is an invalid conclusion. Reason? Both the statements have negatives. If you have two negatives in the statements, we have no conclusion. This is a basic rule of syllogism. Two negatives, conclusion cannot be there. What is the rule? Invalid conclusion. With both premises negative, there is no conclusion. So remember that. Again, another syllogism type, sum A is B, sum B is C, no A is C. first two statements are true, we have to check for the conclusion. Again, by looking at the syllogism, we can just say it is an invalid syllogism. The conclusion is invalid. Why? We have a negative in the conclusion. As soon as you have a negative in the conclusion, at least one, actually only one of the statements should have a negative. That means if you are having a no in the conclusion, you should have a no here or a no here. At least one no. If they both are no, then there is no conclusion again. But if the conclusion is negative, then one of the statements has to be negative. So what is the rule? For a negative conclusion, one of the premises has to be negative. Like that, there are lots and lots of syllogisms. These are the basic three rules we have discussed. Based on this, you can always try a lot of the syllogisms, and I'm sure you'll get it right. Thanks a lot. Cheers.